John Caudwell made his first billion selling cell phones. He's 73 years old, a self-made British engineer who skipped university for a Michelin tire apprenticeship. Then built a company that became Phones for You into the UK's biggest mobile retailer and sold it in 2006 for £1.5 billion. None of that is what's interesting about him. What's interesting is that for over a decade, he's been quietly pouring his money into a marine engineering company in Stratford-upon-Avon with one goal: build a diesel outboard that does something no outboard maker in the world has ever pulled off. Their engine, it launches this year. It weighs more than any 300 horsepower outboard ever sold to civilians. It's mounted at a 60-degree angle that breaks the basic shape outboards have had for nearly a century. And it leans on two of the most respected names in European engineering to do something nobody at Mercury, Yamaha, or Honda has tried. Whichever way the AX300 ends up performing in the water, the engine itself is the most genuinely original thing happening in marine propulsion in 2026. The engine is called the AX300 diesel. 3-liter V6, turbocharged, 300 horsepower, roughly 435 foot-pounds of torque. Caudwell Marine has been working on it since the company was founded over a decade ago, with field trials running through 2025 in conditions ranging from sub-zero cold to subtropical heat. They showed it to commercial buyers at the Maldives Marine Expo in February of this year, which is a deliberate choice because the Maldives runs hot, salty, high-utilization fleets that closely mirror the duty cycle the engine was built to survive. Global launch is happening throughout 2026. The Whole Truth Forum has been arguing about the spec sheet since February, and we'll get to what they've been arguing about. First, it helps to understand why Caudwell built it the way he did, because that decision shapes everything else. A normal gas outboard stands its engine block vertical inside that tall cowling. There is a clean reason for it. A vertical block gets the crankshaft pointing straight down toward the propeller, which keeps the drivetrain simple. Mercury does it, Yamaha does it, Honda does it. Every recreational outboard you've ever seen does it. Caudwell tilted the whole thing sideways. The V6 powerhead is mounted at 60 degrees off vertical, leaned over inside the cowling. The axis drive lower unit that holds the propellers is also angled at 60 degrees. Top to bottom, the engine sits at a consistent slope. And the consequences of that one decision ripple through the entire engine in 3 specific ways that each change how the boat behaves on the water. Tilting the powerhead drops a significant chunk of the engine's weight closer to the transom and lower toward the waterline. On a heavy diesel that already weighs 1,000 pounds, that lower center of gravity matters more than it would on a lighter engine. In a vertical outboard, the crankshaft has to redirect its rotation through right angles to reach the propeller. And every redirection bleeds a small amount of energy and adds wear to a bearing somewhere. The 60-degree mount lines the engine's output up much more directly with the drive shaft running down to the prop. Less work for the gears, cleaner power transfer. And the axis drive lower unit, set at the same angle, means only the bottom section rotates when you turn the boat. The powerhead stays bolted solid. The propellers keep biting at full thrust through a hard turn, instead of breaking traction the way a normal outboard does when the whole engine swivels. This is the part of the AX300 most of the boating press has been missing. The geometry isn't a styling choice or a packaging trick. It's the entire engineering thesis of the engine. And it's a thesis nobody else has had the budget or the patience to test at full production scale. That patience traces directly to the man writing the checks. Caudwell didn't grow up rich. He was born in Birmingham in 1952, raised working class in Stoke-on-Trent, lost his father at 18. He took an apprenticeship at Michelin because the family needed money faster than a university degree would deliver, and he earned a higher diploma in mechanical engineering in his off hours. He worked as an engineering manager for years. When he spotted the mobile phone industry forming in the mid-1980s, he was 35 years old, with 2 decades of hands-on engineering already behind him. That's the part that gets left out of his summary. He's not a tech guy who happened to own a marine startup. He's a working engineer who happened to make a fortune in phones. His other obsession is boats. Between 2012 and 2014, he owned a Formula One powerboat racing team called Caudwell Racing. While every other team in the championship was running two-stroke engines, the way F1 boat racing had been done forever, Caudwell's team raced four-strokes. Four-strokes are heavier, more complicated, and harder to wring race-winning power out of. Conventional wisdom said it couldn't work at the top level. He spent millions trying to prove conventional wisdom wrong. The team folded in 2014 without finishing the season. But the pattern is the point. He bets hard on the engineering approach everyone else has dismissed as impractical, and he doesn't quit when the first attempt doesn't pay off. The AX300 is the same bet on a bigger scale. The marine industry largely ignored diesel outboards for decades because they were heavy and expensive to develop. Caudwell didn't think the obstacles were unsolvable. He thought nobody had thrown enough engineering and money at him. So he built a company in Stratford-upon-Avon, set up a multi-year development program, and went looking for partners who could deliver the parts of the engine he couldn't build himself. The two he chose tell you almost everything about how serious this project is. The diesel block at the heart of the AX300 comes from VM Motori, an Italian company most American boaters have never heard of, even though many of them have driven a vehicle with a VM engine in it. The company was founded in 1947 in Cento, a small town in northern Italy. The original projects were diesel engines for fishing boats and industrial machinery. Within 20 years, they were one of Italy's most respected diesel specialists. And that reputation grew through decades of building engines for cars, trucks, agricultural equipment, and ships. If you've ever driven a Jeep Grand Cherokee diesel, a Ram 1500 Eco Diesel, an Alfa Romeo 164, or a Land Rover, there's a real chance the engine under your hood came from this factory in Cento. They were owned by Fiat Chrysler for years, then became part of the Stellantis group. Then in December of 2025, were sold to a group of Italian investors tied to a specialist powertrain firm called Marvel. So the company is genuinely independent again right now for the first time in over a decade, which is a slightly poetic moment for a marine project to launch one of their engines. The 3-liter V6 block Caudwell uses is a direct descendant of the same eco-diesel engineering family that powered hundreds of thousands of trucks and SUVs in the US market. Caudwell takes that block, modifies it for marine use, mounts it at 60 degrees, and pairs it with a turbocharger sized for the AX300's specific output curve. The cast iron construction is the part the forums keep bringing up. It's heavier than aluminum, yes, but it lasts much longer under continuous heavy load. And it resists the kind of saltwater corrosion that destroys aluminum block engines from the inside out. The weight is a deliberate engineering trade. Caudwell wanted an engine that runs for 5,000 hours without major work, and you don't get that out of aluminum. That 5,000-hour design life is the second number that should make you stop, because it changes the whole economic case for the engine. Most gas outboards are considered done somewhere between 1,500 and 2,500 hours. Caudwell is targeting roughly double the working life of the engines it's competing against, and they built the entire AX300, not just the block, with that target in mind. Every seal, every gear, every electronic component carries the same endurance constraint as a design rule. But a powerhead is only half an outboard. The other half is the drive system, the part that takes the engine's rotation and turns it into thrust in the water through gears, shafts, clutches, and propellers. That's where the second partnership comes in. And it's an even bigger name than VM Motori. ZF is a German engineering company founded in 1915, with about 165,000 employees worldwide. They built transmissions and drivetrains for a huge portion of the world's premium cars, commercial vehicles, helicopters, and ships. If you've sat in a BMW, an Audi, a Range Rover, a Maserati, or a long list of other high-end cars, the gearbox underneath you was almost certainly built by ZF. Their marine division builds transmissions used in commercial fishing boats, workboats, naval vessels, and super yachts all over the world. They describe their installed base as running millions of hours per year of transmission time in commercial service. This is not a startup. This is a century-old institution that builds drivetrains for a living. In early 2023, ZF formally partnered with Caudwell Marine to design and build the transmission system for the AX300. The agreement actually started years earlier in initial design talks, according to Caudwell's commercial director Peter Ordway, and it became formal in October of 2023. ZF built a sophisticated twin-clutch transmission for the engine, which is an unusual choice for a marine outboard. Twin-clutch systems are most often found in high-performance cars, where they shift between gears faster and more smoothly than any human could manage with a manual transmission. In a marine application, the twin-clutch gives the engine an oil-bathed multi-plate clutch that handles the constant forward-reverse shifting of commercial operation without wearing out, and it provides smoother docking control than a conventional marine gearbox. ZF also helped Caudwell with the lower unit assembly itself. The axis drive geometry is Caudwell's own design and their patented intellectual property. But ZF's precision manufacturing experience went into making sure the lower unit could survive thousands of hours of saltwater service without the geometry drifting out of spec. The dual contra-rotating propellers on the lower unit are also part of this package. Two props turning in opposite directions cancel out the torque steer that a single big propeller creates, which improves handling and lets the engine put more thrust into the water without the boat fighting itself. There's a small detail buried in this partnership that's worth pulling out because it tells you how strange the high-end outboard market has become. ZF is also the company that built the 2-speed automatic transmission inside Mercury's V12 Verado. The same German engineering firm now sits inside both ends of the high-end outboard war. They build the gearbox that lets Mercury's giant gasoline V12 shift like a car, and they build the twin clutch that lets Caudwell's diesel V6 deliver torque to two propellers cleanly. When the same century-old transmission maker is supplying the most expensive parts of both engines, you're looking at an industry where the real frontier has moved beyond the brands on the cowling and into the partnerships behind them. Now the controversy, which is the spec sheet number the forums have been arguing about since February. The AX300 weighs about 475 kilograms. That's somewhere between 1,040 and 1,100 pounds depending on configuration. A typical gas 300 outboard weighs 550 to 650 pounds. Caudwell's competitor Cox Marine builds a 300 horsepower diesel that comes in roughly 200 pounds lighter than the AX300. The whole truth thread on the AX300 lit up the moment the spec dropped. One commenter put it plainly, 1,100 pounds per engine better have a good transom. Another pointed out that for the same 300 horsepower output, Cox delivers it with 200 fewer pounds and asked what exactly the buyer is getting in exchange for the extra mass. These are reasonable objections. Weight on a transom is one of the hardest design variables in any boat. It changes how the hull sits in the water, how it handles, what fuel load it can safely carry, and how much stern buoyancy is left in reserve when the cockpit fills with people and gear. Caudwell's answer to all of this is the cast iron block. Heavier than aluminum, yes, but more durable under continuous heavy load. The weight isn't an accident. It's the price of the $5,000 design target. And the 60-degree mounting we covered earlier partially offsets the raw mass by placing that weight lower on the transom than a vertical engine would. The trade is honest. You're carrying more pounds in exchange for an engine that's supposed to outlast its competitors by years. Whether that trade works for your boat depends entirely on what your boat does for a living. A recreational owner running a couple hundred hours a year over the next 10 years will never recover the price premium or justify the weight. The AX300 isn't built for that buyer, and Caudwell hasn't pretended otherwise. The engine is engineered around a commercial duty cycle, and the math only works at scale. A charter operator running 1,000 hours a year clears the gas outboard equivalent fuel bill in a single season and starts banking 5-figure savings annually. A search and rescue boat that needs to start, run, and never fail in conditions that would melt a recreational gas outboard has a reliability case that has very little to do with money. A military patrol vessel operating on a single fuel logistics chain saves a layer of complexity that's worth more than the engine itself in operational terms. That's the buyer Caudwell is courting. Coast guards, commercial fishing fleets, patrol services, charter operators, the same kind of buyer that ordered 92 Cox diesel outboards last November for an undisclosed European military fleet. This is a tightly defined commercial and military market, and Caudwell built an engine designed to fit inside it precisely. There's a service infrastructure point worth raising here too, because it's the practical objection most overlooked in the coverage. A diesel outboard is only useful if there's somebody near who can fix it. The AX300 has its own custom-built vessel control system with NMEA 2000 connectivity, designed for integration with standard marine electronics. The 50-hour and 250-hour scheduled services can be done with the engine still in the water through a hinged service hatch built into the cowling. Major service is only required at 750 hours. That serviceability story is the part that genuinely matters to a working operator, because every hour the boat sits at a dock waiting for a mechanic is an hour it isn't earning. The schedule Caudwell is offering, if it holds up in real-world fleet service, is roughly twice as forgiving as the gas outboard equivalent. The real question hanging over the 2026 launch isn't whether the AX300 is a good engine. The geometry is genuinely original. The partnerships are unimpeachable. The endurance numbers are class-leading on paper. The question is whether the commercial diesel outboard market is big enough to reward a decade of investing and presumably hundreds of millions of pounds of Caudwell's own money. He believes it is. He's been right enough times in his career that the bet shouldn't be casually dismissed. The first commercial fleet operator to put a row of AX300s on a working boat this year is the proof point. After that, the engine sells itself, or it doesn't.